So as you will be aware, I'm sure, yesterday we launched the Cyber Feasibility Report, which is a collection of the findings from the 7 cyber feasibility projects, specifically around what that means for the Cyber Centre of Excellence, and bringing together a number of key recommendations. It's been out just a little over 24 hours. The report's already had 250 downloads, over 600 views online of the people accessing the webpage and summary information there, as well as, I'm sure, lots of interest direct to the project with the work they've been doing. So great interest already just in the first 24 hours. So as I said, we do have a quick and swift agenda. So without further ado, I'll hand over to David Webb, who will just give you a short welcome from CCAV.
Hi, good morning all. So as Mark just said, I'm David Webb. I'm the Head of Innovation for the Centre for Connected and Autonomous Vehicles. So we are the government body looking at how we bring safe and secure connected and autonomous vehicles to the UK. We funded this small round of projects with a very tight timeline and a very small budget to give us some insight into the state of the art of cyber security and resilience at the moment, and to give us some indications of where we should go next. I will talk about where we go next when I come back on the call at the end, but I just wanted to say thank you all for dialing in, thank you all for listening, and thank you very much for all the projects that took part and did a lot of work in a very short amount of time. So I won't hold us up very long. Let us get on with the presentations and get into the nitty-gritty of it, but thank you again for attending, and I look forward to watching your presentations. Thank you very much.
So what we're really talking about is, cyber resilience is at the core of connected and automated mobility. We look at the roadmap we produced and launched last year for connected and automated mobility to 2030. 249 of the 500 or so milestones within the roadmap are linked directly to cybersecurity and cyber resilience. Indeed, sort of TD08, which is sort of the nomenclature for a cybersecurity test center or cybersecurity center of excellence, unlocks many other advantages, in terms of everything from public trust through to certification, through to new business models and operating models for mobility. And what we've tried to do through these feasibility studies is challenge industry, academia, and others to come up with methods to measure and maintain cyber physical resilience and identify vulnerabilities, come up with test specifications for a test facility, and also undergo an exploration for commercial opportunities arising from this research. What we're going to focus on today is the test facility specifications, but I do encourage you to read the project reports because they give a lot more detail about this topic and the others as well. The themes within these projects, we're looking at monitoring of connected and automated vehicles, supporting infrastructure, threats to connected vehicles and threats to automated vehicles, countermeasures, and ubiquitous other to allow the projects to also highlight areas we hadn't focused on. I just want to highlight, this point, and I've made this a number of times if you've seen me speak over the last 6 months. This bulletproof cybersecurity report, provides a great insight into why sort of monitoring of threats and monitoring of infrastructure is so important. Now, actually, it's around, if you add these numbers up, around about 40% of threats to digital systems come from really basic errors and omissions, outdated, unpatched, unsupported components, XSS attacks, poor passwords, SQL injection. SQL injection is still a thing. It's been with us for it seems like decades. But when you think about these threats magnified across a ecosystem of emergent ecosystem of vehicles, infrastructure, third-party applications, all operating together, and supporting a critical national infrastructure, which is important for our economy and our society. The threat and the possibility of critical failure is magnified, exponentially. And sort of leading on from that, if we think about, what is the, how many threats are being identified at any one time. If you look at VulnDB, which is only one vulnerability database, sort of every 26 minutes, a new vulnerability is sort of identified. And actually, over the next 8 years, if the trends continue as they are, actually 250 new vulnerabilities or threats will be identified throughout the average lifespan of a vehicle. So brings us to sort of the key recommendations. We asked the projects to look at what recommendations for a cybersecurity centre of excellence, and I guess it wasn't a huge surprise that the project came back and said, yes, absolutely, this is a requirement. We need to invest in this. And I think when we look at sort of the comments from the report, if I just sort of quote the PNT Cyber Resilience Project, the UK needs a sovereign capability in CAM cyber security, regardless of other countries' positions, and should strive to be a leader. Cybersecurity is a huge strength for the UK. The UK is a trusted provider globally for cybersecurity solutions, and it's only right that we take control of the elements of our critical national infrastructure and own that space and understand it. It feels like an area, as I say, important for our society and our economy, which we can't really contract out. We can collaborate, we can bring others in, but we need to own this ourselves. So, a centre of excellence, it would be absolutely critical to our future. Effectively, this centre of excellence should act as a cluster or a hub for existing capabilities under a single identity. So a hub and spoke model, bringing together experts from academia and industry to collaborate, in plugging gaps and developing new capability. And I think the CCAV support here said that a linked cybersecurity testbed ecosystem cluster, which is, read the report, it's a great acronym, it should include new, existing and testbeds. It should leverage and virtually integrate new and existing world-class cybersecurity assets, including public and private investments. So it's a solid recommendation there. When we look at sort of the next recommendation from the report, it should develop a capability to monitor the operational security of CAM as it's deployed. I think this recommendation at a high level is probably more surprising, actually, that industry is looking for this centre of excellence not only to act as a place for sort of knowledge sharing and developing of new capabilities. Actually, there's a key point here that actually potentially this should grow into the capability where actually we have some kind of centralized monitoring, or we have some capability to monitor this critical national infrastructure of vehicles, infrastructure, and third-party apps as they work together to deliver mobility solutions for the future. And it should have a role in the assessment and assurance of cyber resilience at large. This needs some further thought about how that could be delivered, and who should pay and how that should be built into assurance programs in the future. But I think it's something we should definitely look very carefully at. And if you when we sort of look at that on the DT4CT project, said there needs to be a systematic approach for productive monitoring and identification of operational threats and attacks facing the CAM ecosystem. And you just want to underline, following that recommendation, again, the potential for growth in the number of threats over the next few years, and the importance of not only developing techniques to monitor for resilience, but actually bringing those together into a single place, potentially, to alert society and industry as to the implications of new threats developing. It's another really interesting sort of finding from the CyRes report, which sort of will lead us into the sort of the final couple of recommendations. We think we all understand that homogeneous populations are susceptible to cataclysmic events, and yet more than 25% of the cost of the vehicles is potentially spent on chips and software and type approval aimed at reducing diversity. So if heterogeneous populations are more resilient, we're actually spending time and money trying to remove that heterogeneity and make things homogeneous, which actually potentially makes us more susceptible to threat. So really, potentially managed diversity is the best defense. So next piece here is probably the best defense, because if we look at the design of systems, actually, we should be making the economic cost of exploiting a vulnerability actually less than the value of exploiting that vulnerability. And if we engineer in diversity, as a new way of thinking about cybersecurity and cyber resilience. Not only potentially could we have a more resilient transport system network, but actually, this has spillovers into all kinds of other sectors, including medical, bioscience, and other areas. So I think there's just an interesting point to pick up on this. But coming to sort of the final recommendation, if you go to the next slide there, Mark. Really, this centre of excellence or this capability we build needs to be a base for an ongoing program of R&D. Researching new and emergent threats and developing best practice. And ideas like this quite novel one proposed by CCAV in the Cyres methodology, needs continued investment to try and develop and qualify whether this is possible and how we could deliver it. So if you go on to the next slide there, Mark. So probably the final recommendation is in some ways for us and CCAV to think about this is, from the project, what can we do next to think about, the methodologies and the ideas which have been developed from these projects, which we can start to set out how, potentially future funding and investment could go into supporting, a world-class program of collaborative research and development undertaken with a centre of excellence which we invest in, which will lead to a safer and more secure transport network in the future.
Okay, good morning everyone. This is going to be a really kind of brief whistle-stop tour of the CCAV project. Hopefully I can do justice to a lot of hard work that's been done by a lot of very talented people who've come together to work on the CCAV feasibility study, which focuses on theme 2 for the competition, which is threats to connected vehicle networks. Next slide, please. So going with Mark's recommendation for content, we'll say a few words about the most interesting observations and surprising findings for the CCAV project. Despite the challenges posed in the analysis of CAV networks, which include the complexity of CAV and CITS networks, also we're talking about vast amounts of unstructured data to analyze. We're talking about novel attack vectors, so we're talking about systems which haven't existed before being connected to more mature communication systems to form an even bigger system which hasn't existed before. So lots of opportunities for new attacks. And then also we're dealing with an unbounded operational scope. So, sorry, I need to move my screen a little bit. So despite all of these challenges, which would be it's essentially red flags for any traditional machine learning technique, let's say 2 or 3 years ago, the CCAV consortiums focused on machine learning and identified several novel machine learning threat modeling, detection and mitigation techniques which could be feasibly deployed at scale. The takeaway from this is we very much focused on the ongoing deployment and not just testing. Next slide, please. The biggest challenge to come out of the project is basically regarding data. So the application of machine learning really requires large data sets to allow us to extend the reach of the cybersecurity and CITS, and those data sets will have to be representative of real world systems and real world ecosystems of vehicles. The reason for the modeling is to basically train the models in the CSCE, and then these machine models can be deployed at the network edge, and then this gives the capability to rapidly detect anomalies and in these critical data flows, basically at the closest point source to the vehicle. In almost all the cases, these data sets and streams are siloed within private organizations or within public transport sectors. So there's a lot of parallels between this kind of data and also the, let's say, the training data that's used for training AD systems. So each company has their own set of edge cases, and if you ask if we got all the edge cases, the answer is probably yeah, we've probably got most of them, but they're all different edge cases and nobody has the full picture. So collection and aggregation of all this data for the benefit of society is another major challenge. So the Cybersecurity Centre of Excellence must form the cornerstone of a UK-wide collaboration to achieve this. Fundamentally, any sort of collaboration of this nature is a question of trust, and a long-term investment by the government in the establishment of the CSCE hopefully would go about creating the conditions to build that trust and allow the facility to grow. Next slide, please. Recommendations for further CR&D topics. So CAV Shield recommend further research to assess and validate the novel data techniques that we proposed in the 2 reports. Taking a risk managed approach, this could be achieved in a number of ways, possibly in parallel. The first recommendation would be a deployment on a closed proving ground environment to research and develop the working methodologies for threat modeling, detection and mitigation. There's a lot of advantages to deploying on a proving ground in terms of closed network, visibility of the full network, and also in terms of safety. And then also a second step would be deployment in a small-scale living lab style program to verify the effectiveness of the possible solutions in real-world conditions with the real-world, let's say, background noise and network traffic. Okay, next slide, please. So our core recommendations for the CSCE are that the CSCE must be a system of systems that integrates the various architectures, technologies and techniques required to accelerate the safe and secure development, trialing, testing and deployment of secure CITS and fleets of CAVs. So very much a holistic approach and basically able to cope with the end-to-end system. It must tackle both the CAV and the infrastructure points of view for data flows. It must be able to offer and develop a collection of intelligent methodologies for cybersecurity. So again, centering around the machine learning methods to extend the reach and to be able to process the volumes of data that we're anticipating to be in the ecosystem. Provide a testing and evaluation capabilities for CAVs and the CITS infrastructure. So dealing with the end-to-end systems and not just the end nodes, which would be controlled by the system, let's say the system manufacturers, so the vehicles and the back ends, but we also need to be able to have visibility and to be able to monitor the network in between. Provide certification and assessment of all subsystems, again for an end-to-end CITS. And also to have the human and physical resources and a supporting national ecosystem, basically talking about education and developing relationships through industry and academia and government, and to be able to develop those relationships and strengthen them in the UK. And then finally, again, moving my screen. Final recommendation would be that we would, our long-term goal would be to have real-time attack monitoring and attack mitigation capabilities within the CSCE to basically support ongoing deployment. Okay.
So the aim of our project was to try and get an understanding of typical CAV testbed environments, discover potential attacks against the systems, to understand the threat actors and their motivations and identify ways to secure the environment. We had some technical limitations during our project in that we weren't able to get access to representative technology. So if anyone happens to have any bits of technology that use 802.11p or just anything that's, you know, CAV infrastructure related that we'd be able to test out, please do contact me or any of my colleagues. We'd be very interested in collaborating on some research work. So because we didn't have access to the actual hardware, it ended up not really being an attack path mapping exercise, but more of a threat modeling exercise. So within the report, we go over the technology that makes up the V2X infrastructure. We talk about the different types of attackers that are likely to target the infrastructure. We work through some examples of how an attacker might gain access to the network, navigate around it, what kind of attacks they might do. And we talk about some of the remediations within this domain. And we also make recommendations that are quite similar to what Richard was saying earlier about there being a center of excellence or a consortium that kind of sits above all of the V2X infrastructure and helps to facilitate knowledge sharing and just generally promotes good secure practices within the domain. Can I get the next slide, please? So just for a little bit of context, I'm going to touch on the protocols that are used within these networks. I'm sure one of the other projects will talk about them in more detail. But the two main protocols that I want to talk about are CAM and DENIM. CAM stands for Cooperative Awareness Message, and DENIM stands for Decentralized Environmental Notification Messages. These are both EU standards, but we intend to use them in the UK to ensure interoperability with the EU. CAM messages are used to provide a kind of heartbeat for systems within the network. They allow the stations to maintain knowledge of each other. So the current location of the vehicle, a unique identifier, that sort of thing. Whereas DENIM is used more for like situational awareness. It allows vehicles and other nodes to pass on information about, say, there's black ice on the road ahead, or there's been an accident. It just allows kind of all the vehicles and all the nodes within the network to maintain awareness of what's going on around them. These protocols are both transmitted using 802.11p in this new OCB mode. And that OCB means outside the context of BSS, which basically means that all the nodes within the network aren't joined to like a WLAN. They're kind of, it's completely ad hoc network in the truly free sense of the term, in that anything can join to the network. There's no authentication, there's no kind of association. It is literally just, if you're on this frequency, you can transmit, anything can pick it up. So that's kind of what part of the backbone of how the V2X infrastructure works. They need this completely ad hoc network so that any vehicle can join and communicate with any other node within the network. But it does create some security limitations. Because they're not joining to a base station, there's no authentication and association. And just because anyone can send anything in the network, really. When I was reading the standards documents, I found that there's a lot of mentions of security will occur at another level, or just straight up saying that security is out of scope. There's not been too much consideration for security in this domain, I don't think. So, I mean, with the threat of random people being able to join, you've got the potential for people to send malicious data, to try spoofing data. They can replay previously sent messages. And this has a real risk, not just for manipulating the models that the vehicles are working on, but also for denial of service attacks due to using up all the bandwidth. I also noticed that the CAM and DENIM's basic services, which are these systems on the vehicles and on the other nodes like the roadside units that will process the messages being received, they will automatically try and process any message they receive. Like they'll just decode it and process it to try and work out if it's valid or not. So an attacker could just replay endlessly other messages and cause a denial of service at the vehicle level. So that vehicle would no longer be able to receive messages from other vehicles or other nodes, which is a big risk to security. There is, in the standards, there is mention of a malicious behavior detection system, but it's not really very well defined, which is an issue because there needs to be a well-defined method of determining what malicious behavior looks like within the network and how we can remediate against it. Within the report, we go in quite a bit more detail than I have just now about protocol level issues, but yeah, I would kind of be here for much longer than 10 minutes if I talked over all the issues we discovered. So I'm going to move on to talking about threat actors targeting CAV networks. Can I? Oh, thank you. So we've tried to put together this model of the different types of threat actors that are likely to target CAV. We've put them into these levels where at the higher level, we've got the nation states, groups like APT32, who are well funded. They're incredibly knowledgeable. They've got a lot of resources, but there's few of them. And at the other end, we've got like the bedroom hackers and the script kiddies who have literally just downloaded some random tool online and, they're just playing around really. They're not really trying to do any real harm. They're just messing around. So in the report, we talk about the kind of goals of all of these different levels of attacker, excuse me, what kind of methodologies they're likely to try, and just generally discuss how they can move through the network. If you click again, you should have another, yeah. So this is one of our example threat models that we've generated. This shows how someone could initially take an unauthenticated external point of view and move through to being able to compromise a roadside unit. So we've come up with just a few example scenarios. They're not, we're not saying that these will happen, they're just examples of things that could happen. So in the scenario for this diagram, we've come up with the idea of Bob, a guy who lives in a small village that's got smart roadway running through it. Bob doesn't like cars speeding through his village, and he's read online that there's these roadside units on smart roadways placed every 500 meters, which control the speed at which the cars drive. So he decides he's going to target them. He spends some time trying to learn about hardware security. He's already got a little bit of a background in hardware, so he knows his stuff a little bit. He decides he's going to go to one of these roadside units. He gets a crowbar, he levers the box open, and suddenly an alarm goes off. And Bob panics, runs away. The physical tamper detection system within the roadside unit had detected that door opening, and it had automatically sent a message out to the rest of the network saying, you know, ignore this node, it's been compromised. So Bob wasn't able to target that. But Bob decides, well, the other devices in the network talk to the roadside unit, so I guess I'll just target them. His neighbour happens to have got a brand new intelligent vehicle, which he knows connects to the roadside unit. So Bob does a bit of research on his neighbour's car and discovers that the car generates a Wi-Fi hotspot, which the driver or passengers can connect their phones to get internet. He reads a forum and he finds that there's some abusable authentication vulnerabilities which haven't been patched in this particular vehicle. Bob's able to gain access to the network, and once he's got access to the Wi-Fi, he's able to pivot around inside the car's internal network until he finds the service that lets it interface with the RSU. He does a bit more research, and after some trial and error, he works out how to manually generate denim messages. Using this, he sends a bunch of messages to the roadside unit saying that there's black ice all over the road. And the roadside unit, it collates all these reports and it decides, yeah, there probably is black ice on the road, and automatically lowers the speed limit in that area to a much lower speed. It automatically updates roadside gantries, overhead gantries that have speed limiters on them. And for any autonomous vehicles coming through, they're automatically adapted to this speed. And you know, Bob's happy now. He's got his goal. He's slowed down the cars. So next slide, please. So what are the solutions? There's no silver bullet in this. It's a multifaceted solutions, really. We need to be able to identify malicious nodes. So when Bob opened up that roadside unit, an alarm went off that detected it was open. We can now consider that data unsafe and ignore it in the rest of the network. But we weren't able to detect it in the vehicle. So we need robust tamper detection within every node within the network. We need a way of maintaining custody. We're proposing that data is encrypted at every level. So once the data comes from the car and it goes off to the roadside unit, the roadside unit collates all the data, sends it onwards to perhaps some kind of hub or elsewhere. Or if we sign the data at every single level and we later discover there's been a data tampering incident at some point, we'll be able to work out by backtracing through these where the tamper had occurred, and we can investigate. We also think there's the big need for the consortium that Rich talked about earlier, where people can get resources on how to secure their new devices, on how we can share information within the network to ensure that everyone is secure as possible. We believe that information sharing between stakeholders is key, and that we should maintain security in the entire ecosystem. We also think the robust testbed security is needed, and we've come up with proposals for a series of robust tests that vehicles must pass before being able to come onto the test beds in the first place. Next slide. So in conclusion, there's a lot of need for better security research in the protocols area. I'd implore stakeholders to stop just saying security will occur elsewhere and take matters into their own hands and secure the devices themselves. We also think that information sharing is incredibly important. We'd also like to do a little bit of self-service and say that if you share your new developments with researchers early on, they can help you find the vulnerabilities before they go out into the real world and the bad guys do. And at F-Secure, that's our day-to-day work. So if you've got any technology that you would like investigated, please do reach out to us. We'd love to help you out. We'd love to be able to help you find any vulnerabilities. And thank you for listening. That is me finished.
Hi, I'm William here from Cisco. So I'm going to introduce you to the Bearcat project, which refers to baselining automation response for CAV testbed cybersecurity. Thank you. Next slide, please. So our project responds to the theme 2 in this particular call, which is threats to connected vehicle networks, in order to determine the physical and the virtual testing to identify and mitigate against complex threats. So the overall aim of our project really wants to assess the feasibility of a coherent and holistic approach to cyber testing for connected vehicle networks. So within the past 3 months, our contributing partners, working together very, very hard to study on security testing connected vehicles and roadway communications infrastructure. Our participating partners include Cisco, Millbrook, Telefonica, and the University of Warwick. The first part of our project really discusses the technologies underpinning connected vehicle systems and cybersecurity threats to those technologies. Once we understand those threats, we feel that they provide a baseline for understanding the cybersecurity implications of CAVs and those of the communication systems that enable or enhance their operations. We find that cybersecurity in a complex ecosystem cannot be readily guaranteed. It's not that easily solved. However, threats from attack can be reduced to an acceptable level of risk. Therefore, we find that testing task is very substantial, but more importantly, automation of testing is essential. We have got engineers in our group to discuss the current way of testing, but also the future automation of testing approach is needed. A systematic response to incidents together is also needed, so that we proposed a security testing framework which can keep the cybersecurity risks in the CAV ecosystem to a residual level throughout the life cycle of CAVs. We want to highlight the keyword life cycle of the CAVs, not just from the manufacturing and deployment side of the CAVs. Currently, according to our initial interview and also our initial review, there is currently no single test facility specifically focused on CAV cybersecurity in the UK and also across the world. Therefore, we propose that a cyber testing facility can offer multiple layers, including both infrastructure and service layers, such as physical infrastructure, telecommunication capabilities, connected applications, and service, as well as business functions. The initial assessment from our project have concluded with a business case for establishing a CAV, with more details in the report. And we feel that a CTF will require a highly trusted collaboration with partners to manage commercial, managerial, and technical risks. Next slide, please. So in terms of recommendations for further CR&D topics, what we have recommended in our report is to invest in a security framework, as you can see on the right-hand side, with a few texts highlighted in red. And they include reference architectures to derive attack surface views. They also include model cyber threat with TARA, which is threat analysis and risk assessment. Include security testing and associated management. Also include CAV cybersecurity knowledge base, which will provide a center of excellence for the future knowledge generation. In this kind of the exercise of referencing to the cybersecurity testing framework, we have identified that communications infrastructure and cloud services as a key area for focus for the further investment. We also find that the critical components within the framework could be spectrum allocation. Therefore, we might want to consider Ofcom participation in the future activities. Next slide, please. So, in terms of the core recommendations for our cybersecurity testing facilities, we have gone through all the global industrial driven standards, and guidelines, regulations, and legislations. We have found some of them are baseline documents which have been referenced multiple times, including ISO SAE 21434, road vehicles, NIST cybersecurity framework of the United States, J3061 United States, PAS 1885 UK, and TR68 Singapore. So we feel that there are some baseline documents which are quite important for the understanding of this particular sector. But more importantly, we feel that UK is in a great position to demonstrate the global leadership in this space by establishing a focused cyber testing facility. However, operating a testing facility is quite complex. It could involve detailed organizations, governance, and security procedures. And therefore, day-to-day, and also we need to be counting the day-to-day maintenance of facilities and management of the customers, and they have to be all managed in a controlled environment. Therefore, independent and impartial testing is critical to the public acceptance of CAVs in the UK. One of the most effective course of actions from our studies is that the future CTF, which is the cyber testing facility, should be co-located with an existing testbed because of the vast amount of the expensive overheads and setup costs could be incurred during the management of test facility. And we feel this could be the most cost-effective action for a UK cyber testing facility with an existing testbed. Next slide, please. So in terms of our interesting observations, what we have found is cellular V2X could become the global V2V, V2I connectivity standard, and we need to prepare for that with testing, evaluation, and development of standards. We also discovered that cybersecurity is an evolving environment which is required throughout the life cycle. Importantly, we need a framework for that risk assessment, mitigation, and the best practices. Having said that, this is an evolving environment. Having said that, this is a life cycle of cybersecurity for CAV. We feel that the certification of the cybersecurity testing process is required in addition to the certification of cybersecurity, because sometimes it's difficult to say how would you be able to certify a CAV with a proper level of cybersecurity. Therefore, we want to highlight that our interesting observation want to highlight that the testing process itself needs to be certified. The procedures around the certification process could be based around ISO SAE 21434, which could be regarded as a superset of the UN's ECE CSMS, and they are likely to be embraced by the current OEMs and vehicle manufacturers. Lastly, the UK, as a leader in cybersecurity, vehicle and communication technologies, could provide centers of excellence in understanding, testing, and countering of threats. And the last point we want to highlight is the UK skills base can be used to protect the CAV ecosystem and also help with the development of the UK CAV industry.
You mentioned earlier on the variety of projects, and this project does require a slight change of gear. I guess each one needs a slightly different mindset to approach the presentation. I'll be talking about position, navigation, and timing. Could you go to the first chart, please, Mark? So for those who aren't familiar with GNSS, satellite navigation, it's worth stressing that it is vulnerable. There is no, in open service GNSS, there is no inbuilt authentication or signing of any type. The open service is exactly that. They're broadcast signals. The ICD is well known and understood, has to be for the receivers to be developed. And so it is vulnerable to attack. Jamming is one form of attack, obviously, and then spoofing, where false signals are generated, is another one. So this has led to the use of other external signals or sensors to supplement and to check the integrity of PNT systems based on GNSS. For safety critical systems, then a credible means of assessing the robustness and integrity of a GNSS based position, navigation, and timing system is required that's agnostic of the solution under test. What I mean by that really was highlighted by the comments that Rich made in his introduction about the dangers of homogeneity. The assumption here is that a system of systems will combine sensors in a number of different ways, and we need to be able to assess the resilience that those give us in a single test approach that is not specific to the technology deployed. Next chart, please, Mark. So what did we do? Essentially, what we were trying to do is establish the feasibility of a live-to-lab observational approach to assessing resilience in PNT systems. So the first thing to do was establish a baseline, if you like. What did we need to do? What would such a test bed need to do? And that was achieved through some extensive consultation, a series of fairly in-depth interviews were done. There was a literature study that was completed. Having established then what we believed a testbed would be required to do, we had a go at seeing if we could use a PNT attack emulator and achieve the things that were required of such a testbed. So I'll mention briefly what we actually did, and then come on to the recommendations. Next chart, Mark, please. So the PNT attack emulator interrupted the signal from the GPS satellites, or the GNSS satellites, going into the system under test. You could do this with a hood over the top of the antenna externally without interrupting the system at all, or you can do it in an entirely conducted way, that is interrupting the signal, the RF signal between the antenna and the receiver, and replacing it with a synthetic signal. So the overall approach is to replace real live sky signals from the satellites with synthetic signals, which we could then mess with. We could add other corruptions in order to see if we could upset the navigation and timing system. The key thing here is that we wanted to be unaware of what other signals were being used, what other sensors were being used for positioning. So we had to make sure that the synthetic signals were indistinguishable from the real thing, and that the timing was such, the latency was sufficiently low that when fused with other sensors, a credible position navigation timing solution was derived. And then we had to make sure that we could actually generate a range of pertinent and realistic attacks. Next chart, please. So we did this in a couple of stages. We did some testing in the lab, both jamming and spoofing. This was going to form the baseline, if you like, to see if what we were able to achieve on an actual vehicle was representative. So in the lab, we mixed the GNSS signals generated in a simulator with the output from an interference source, in this case a Roden-Schwarz vector signal generator, and did a range of jamming trials. We also did some spoofing tests. So this involved either adding to the live sky signals another set of signals which the receiver could lock onto and derive false pseudo-range information, or where we would introduce a false signal which would have a pseudo-range the same as the observed real-life satellites, but would introduce errors by passing false navigation messages, which would then lead to the corruption of the PNT solution. So we did that in the lab first of all, and then we moved out into the field to see if we could produce the same sort of effects by introducing those synthetic signals, those jamming signals, on a live vehicle. And also we had a play with what you could do with interfering with an RTK base station. Next chart, please. So the outcomes were that chosen lab to live approach, starting with the lab-based testing and then moving on to live testing, did actually work. So from a feasibility perspective, we were able to reproduce some of the attack vectors that had been reported to us in that initial roundtable investigation stage. There really is a critical need to establish a workable framework for the evaluation of PNT resilience in CAV, and it looks like this attack emulator is a credible basis that we could do that. But in order for that to get traction, the credibility of such an approach needs to be demonstrated. Spirent and WMG, who are the key partners in this, are continuing to work together on the provision of such services. We had 5 key recommendations. that vehicles should be tested in a variety of driving modes, if possible, so GNSS only and with the fusion of GNSS and other vehicle onboard sensors. That a set of standards needs to be created to measure the resilience of PNT attacks or resilience against PNT attacks. A test facility should subscribe to GNSS threat monitoring. So it's a cat and mouse game. Threats are going to be changing and evolving, and those need to be represented in the test strategy. And so subscribing to some threat monitoring is important. There should be a directory of facilities available and their supported aspects for cybersecurity testing. And finally, that a test facility should consider testing classes of CAV beyond automobiles, so UAVs and so forth. Just to conclude, to emphasize that the system of systems approach is really key. So systems and facilities need to be resilient in the face of PNT attacks, not just at the component level, but rather at the system of systems level. Hardening against attacks risks new attacks finding novel paths. And so having a system of systems approach and being able to test at the systems level is what we were aiming to demonstrate the feasibility of, and indeed we succeeded.
Hello all, I'm Erica Yang from Chiltern Computing. I'm here to present the DT4CT project. DT4CT is a project, it's a collaborative project between Chiltern Computing, SDFC Hartree Centre and Oxfordshire County Council and Haduma Limited. In 2019, 80% of the cyber incidents in the smart mobility domain actually took place remotely, i.e. for CAV CAM systems, connected autonomous mobility ecosystem. So you can see a huge amount of attacks took place without ever get close to a vehicle component or have any kind of access to that. So that's important context to bear in mind. That's where we started our project. Now, in the project objective, we started, as you can see from the title of this project, is that we're focusing on two things. One is the digital testing. Digital-based testing, how does that complement with existing physical test, the CAV test bed, and also perhaps even more importantly, this digital twinning concept, i.e. how does the evolving nature of the CAV network system, ecosystem, the data from those ecosystem can play in this testing and certification framework. Now, as you can see this diagram here, that's really no short of things to be tested. Once a vehicle or CAV components left the manufacturing, left the factory, the question is that one of the critical questions we ask is based on what evidence, if you like, from the data, then you can prioritize your test effort and have certain degrees of assurance of the validity of the test will give you the type of assurance you need. Well, this is a small feasibility study. We haven't answered all the questions we originally, if you like, all these are very big questions. So one of the outcomes from the project is also understanding the gap and understanding the business opportunity to take those forward. I'll give you an example, penetration testing, which is a very standard practice when one deploying a critical component into a network, into a transport network, for example. Then one of the central questions framing under the context of our project is that we ask is, what does it give you? How does it, in terms of testing, certify through a penetration testing, what assurance does it give you? Now, in short answer, it only gives you a snapshot at that point in time based on people's understanding of the vulnerability, understanding of the threat landscape, but it doesn't, from an operational point of view, it doesn't give you the assurance over time, which is the focus of this project. Next slide, please. Yeah, hello, hi. Well, we have the report, the Zenzic report, as well as the project report. You're very welcome to read. So I'm not going to repeat all those findings in detail here. Here I'm actually emphasizing on the interesting observations that we were asked to present. Now, again, some of this, there's a 5 bullet point, is quite a bit information here. But the key thing here is that perhaps I can pick on a few, perhaps the most contentious one. One is the first one, in terms of the interest of observation, is that we study quite a lot existing standards, particularly in European context. The CITS project, the existing large-scale testbed, the test that they call it plug test, and the standards in that space. Actually, what we find is that in terms of the cybersecurity standards, there are very limited standards available in this, particularly from an operational point of view. This actually echoes one of the previous, I believe, is FCQ's finding. The CITS standards, actually, they emphasize a lot on the, if you like, the identity and trust management, and therefore it does provide the important foundation for secure message exchange and identity verification and all that, if people adopt them. But in reality, those standards, if you like, is one of the important steps, but only one of the steps. When it comes to operational, there is a huge space of operational security that those current standards are really not covering at all. That's one of the first interesting observation. Secondly, cybersecurity is we have seen quite a lot of statistics and research, but in reality, from what we have done, we research into the last few years, the funded project, if you like, projects that mention security in their initial briefing or in their project's website. Actually, if you at the end, very small fractions of them actually delivering security findings or outcomes or solutions. So that's what I mean by, in reality, security is not being prioritized as most important area for research for most projects. I know it's a bit controversial, but I think depends on the player. If you're a security company, that's a different, but if you are autonomy company developing AI software, it's sort of understandably that security is something that perhaps not as important as developing the autonomy, automation, and AI at the front. Now, another interesting, perhaps, I think it's also very important observation is that the last bullet point, again, is from operational point of view, i.e. once a vehicle or once device, if you like, in this ecosystem left the factory, there are very limited understanding, not to mention common understanding about what is the most significant attack, what is the most significant vulnerability, and what are the most important risks. What I mean by that is really, you can get people's opinion, you can get findings, people developing methods against particular type of attack or methodology, but in reality, it's quite hard to have the hard evidence to understand how does that really influence our prioritization in terms of our efforts, in terms of our securing systems approach, and etc. So that's a big, from what we have seen, what we have researched, that's a big gap there. Next slides, please, Mark. Now, the next, it brings to the, because I try to not to put too many words here. If there's one biggest, it's asking the biggest challenge to come out of the project. Really, I think, as several speakers previously mentioned, standards. I totally agree with that. If I only pick one standard, I actually say this standard, data standard, is really underpinning many of the other, if you like, standardization efforts we need to put in place before we consider many other standards, if you like, cybersecurity methods or tools or methodology, be it conventional threat detection or AI-based and emerging one. So there is a whole range of other things, but they all hinge on these data standards. But however, this is actually, again, actually in reality, it's a very contentious topic, I would say, because actually in reality what we have found, we have been trying to talk to the stakeholders in this place, in this ecosystem, trying to understand first of all what type of data they have, and second what are they doing with this kind of data, particularly from cyber security point of view, threat intelligence point of view. But actually I believe one of the also mentioned several times by previous speakers is that we call it the data is actually important asset. Is people are very precious about the data they have, and a lot of the methodology is actually hinged on the data they have. Now the problem with no data standards available for describing the type of basic characteristics of the data set. I mean, for example, how does the systems, the logs, how does the systems basic configurations and specifications, and also how they implement the standards and all those data. I mean, understandably, people can be quite precious or quite protective about those. But however, without this type of standard, the problem is that all the tools, all the methods, all the systems developed, all the technology providers will end up providing their tools, technologies, methods still in a silo. What that means is that it will be hard to use, hard to evaluate, their vulnerability, how to assess their ongoing vulnerability and all that. So as a result of that, as you may remember, the first slide, we've got a complex landscape of systems evolve. As many systems evolve, especially during the operational stage, then it's any vulnerability within that ecosystem becomes the weakest point of the system as a whole ecosystem, that becomes the easiest target for attackers or hackers to get into the system. So as a whole, making it very vulnerable. On the other hand, we also have, this is difficult to establish standards, is also to do with the fact that data standard is actually, it takes time to develop its value, because often it's only when you have enough data, enough can be in terms of volume, but arguable, because how do you know the data you have seen or data you have collected is representative enough? Historical events does not necessarily mean what's going to happen in the future. Now, there are two types of R&D topics we listed here. The top, roughly two parts. Part one, top three, is about the kind of new type of testing we can do, really about what kind of digital testing and capability we need. Second is pointing to the kind of more capabilities needed by a national testing capability for the cyber facilities. These are very important because being open and being accommodated is crucial for the success of this new cyber centers of excellence we are aiming to create. We have further details in our report. Next slide, please. Yes, in terms of the cyber facilities, we've also been asked to provide input to a new cyber facilities or center of excellence. Now, again, there are details in the report, much more elaborate explanation about what this means. But the first, I would like to make 3 points here. The first point is that the importance of standards for cybersecurity measures and how you quantify the basic measures you use to quantify the threats, threats and derive those from different systems, different boxes, be it individual, if you like, the boxes or components within the vehicles, or in the infrastructure, or in the cloud system. As you imagine, there's a whole spectrum of different systems or components involved in this ecosystem. So we need to make it accessible. Standard is the key to make it accessible for all in the ecosystem, in this ecosystem community of environment. Second is that now, in order for the new players to come into play, which is crucial for the flourish of UK CAV ecosystem, we believe that this kind of new testing capabilities to allow a scalable new testing capabilities allow new players to independently testing, but also digitally testing, i.e. we propose the concept of testing as a service, because this is a very complex situation, you do need to involve a lot of technical expertise in setting up the testing capability, but also driving the threat intelligence to need it to understand what is the priority or what is the most important threat facing your devices or the systems you are developing. So we are proposing the scalable testing methods, which is again elaborated in our report. Number 3 is that the monitoring. Again, that goes back to the point we made earlier. It's about how do you know what you are testing does give you the assurance you need. And that's really about enabling the stakeholders, again, this national facility context, enabling stakeholders to act tactfully, systematically, understanding the threats that are facing specific to their boxes, to their system, but also about when and where and how to invest their security hardening measures. So that completes my presentation. If there's any questions, do feel free to get in touch directly with me on Zenzic. We have 3 reports available for you. Well, 3, 1 public report and other reports as well.
My name's David Price from Atlas IDIADA, and we've been leading the Miley cybersecurity study together with our partners. So Mark, if you'd care to move on to the first slide, please. As you can see, there was 3 of us in the consortium, ourselves, IDIADA, and our partners, Cryptolabs and Tesca Labs. And you can see from each company's notes there that we're bringing together 2 companies who are experts and specialize already in cyber and encryption, and putting them together with IDIADA's background in automotive, particularly our experience in vehicle testing and homologation. And all 3 companies have got a real vested interest in understanding cybersecurity standards, testing infrastructure, and how that's going to evolve in the future. The 3 of us have worked together in the ETSI plug test for CITS, where last year we brought together with different vendors PKI security for the first time over 802.11p, and that used facets from each of the company, and we'll show them again in the demonstration that we've done with this project. Thank you, Mark. So within Project Miley, the objectives have been to look at cybersecurity testing standards and compare them to typical communication networks that we find on today's vehicles. It's worthy of note just how many legacy communication networks are still there in a modern vehicle. We've brought our different experiences together to understand how best we can apply the standards to this automotive cyber problem. The graphic on the right shows you, is seen in more detail in the report, but it's enough here, a bit of an eye chart, but it's enough to show you that there are different threads that must come together to properly develop and test security controls. There are different phases of validation and certification, all requiring different testing approaches. So with our testing knowledge, which is all derived from real practical experience in working with vehicles and security systems, we can see how that is going to have to play out in the future. We've used that to help define the testing requirements, but looking very much, as I say, at the real practical parts and our experience. The project has also allowed us to demonstrate how we can combine modern security mechanisms with older legacy networks. So I'll show that a little later on. Obviously the project is all about exploitation and how we can build on this and move forwards with what we've learned. Thank you, Mark. In terms of the findings during the project, the key points are these: that there really is no single body driving the market in terms of the use of standards and the approach to testing and certification. I think this is a common theme that several of the speakers have already mentioned. As a result, both the standards and the vehicle networks have multiple gaps when it comes to cybersecurity. This is particularly true once we look at the communications inside the vehicle, where it's clear, as I've said, there will be legacy networks in use for years to come, but they're all now connected to the outside world. So we took 10 current production vehicles completely random ones, basically ones that we had around and we could get our hands on, and looked at very quickly at what's there. And you can see the chart below shows that there is a bit of a mixture. Nothing is perfect today, and there's a lot of work still to do. So when we look at the challenges, we've found ourselves at the convergence of some very different worlds where automotive, cellular, ITS, IoT all come together. And we see the biggest challenge is going to be harmonizing these approaches, the standards and the regulatory regimes to create the cooperative ITS systems that we're going to need for our future smart cities. We really need to find a way to use the standards to drive the improvements in CITS and cybersecurity. Thank you, Mark. Turning to the recommendations, we believe that we need to create these formal links between the different standards regimes. So if I take a future smart city example to give a context for how it's going to be very different from our traditional approaches. Let's imagine something where we need to take health data that's collected from people living in the city, combine it with pollution monitoring, and use it to control traffic, and all that in real time. All these different links to different systems that shows where the problem is going to be and how that can easily fall foul of cybersecurity and be manipulated by other people. So that shows how collaborative and CR&D, collaborative research, is definitely going to be needed to deal with those kind of security problems. As we know, the second point is that production vehicle systems, as we've already heard, are designed down to the lowest cost, which means limiting resources in terms of bandwidth and processing. And so we're really going to have to improve our cryptography skills for these kinds of limited performance systems, especially given the future quantum computing capabilities, where brute force cracking of current algorithms is just going to be a real problem for everyone. Again, collaboration will be the best way to come up with new cryptographic algorithms. And finally, we need to ensure that the cyber skill centers that everybody's been talking about bring together people from all types of industries and allow an environment in which we can get the best of the best, and that can flourish there. So that's our test facility on the right-hand side. One thing we think that it would be really good is to publish results. We've seen significant improvements in security in the IT industry, driven by the pressure created from public announcements. That's, I think, one of the key things for this facility. The rest of the recommendations that are detailed in the report talk about the details of the test systems, how you need to be able to reconfigure them rapidly and easily, how you need to coordinate control across all the different test vectors, and stress the system under test so that you can really manipulate everything around it and provide a properly coordinated attack and stress capability to understand how the system performs and ensure that it will survive in the real world. So if we move to the next slide, please, Mark. This is the demonstration that we've built here, and we're showing how to mix modern PKI security with traditional CAN vehicle network. We chose CAN because it's pretty much omnipresent, used both inside and outside the vehicle because it's used for some EV charger connections, and it has absolutely no security built into the base level. So we've taken two of our IDAPT controllers. Those are the ones that you can see on the lower picture on the right. Apologies about the picture. This was in the very early lockdown phases, so it's the best we could do without being able to bring it all together. But we have the two devices, the IDAPs talking together. They can talk, there are general purpose controllers, can talk all kinds of languages, cellular V2X, SATA to 11P and all the rest of it. But here we're choosing to talk over CAN, and we're also gathering authentication certificates from the PKI server over cellular. So each of the IDAPs is running the links to the PKI server to get its authentication certificates. It has a locally stored hardware security module, and it has the application. In this case, one's pretending to be a vehicle onboard unit and one's pretending to be the off-board charger for the vehicle. And then they talk over the CAN bus. But they now have a secure regime in which to talk. And then we've hooked in to try and attack them on that CAN bus. We were going to try and show this live, but as you can see, it's just not going to work here. So there is a link at the bottom of the page where you can get through to that and understand some more. So to sum up, we've shown that there are significant gaps in what's currently available, in the standards, the way things are used on the vehicle. And I hope with the demonstration that we've done as part of the project, we've shown how we can adapt security approaches from different regimes to make large improvements in the security of vehicle systems. So we're really looking forward to the challenge of taking all this on to the next level and working with you. Thank you very much.
I'm Paul Jarvie. I'm the Director of ACEN, which is the UK's Automotive Electronics Innovation Network. I'd like to take you through ResiCAV. This is about resilient, connected and autonomous vehicles, and we're addressing the theme 1 of the CAV cybersecurity call for monitoring. We had 11 contributors on this project, a fairly large number. Just to quickly go through those names: Hariba Myra, Thales, BT, WMG, the Centre for Modelling and Simulation, Oxford County Council, ACEN, the University of South Wales, University of Bristol, Coventry University and National Digital Exploitation Centre. So a fairly big group of contributors, and just really to stop on mention that for a moment. Key point here is that it's a representation of world-class powerful research. It's R&D, it's the industrial capability on infrastructure, test beds, autonomous deployment and cyber resilience across all areas of adversarial context. The other point here is there's a very strong cross-sector representation, and in addition to that, the academic partners provide a representation of the critical element of understanding the emerging and global challenge, which is providing the latest research in this space. So just to really outline what the problem space as seen by the project, CAVs and their infrastructure are now part of a complex super system, and we've heard the previous speakers touch on these points. It must operate within a reliable and safe envelope, and it must also be resilient in the face of cyber threats. So currently, at the level of demonstrators of CAVs, there is a risk that as we scale that up, as we scale up the size of deployment, that we could face a catastrophic failure if we did nothing. So what you're seeing in this diagram here, that's really in the center of the slide, to the right of the slide, sorry, is the way in which the very fact that we've got such a strong contribution between the different elements and cross-sector that are coming around this area as building up part of a centre of excellence. And really within that, the two big elements that we're going to touch on here is the sustainable methodology and the commercial viability that's required to be understood as part of that. Excuse me. The key outcomes and responses really guiding us on building the partnership towards groundwork and experience of work in this space, new operational requirements for resilience, and a feasibility study on the methods for implementation. A key strength of what is brought together here is, of course, the mixed discipline and thinking. Within this project, you have everything from automotive, cybersecurity, network operation, high performance compute, electronics hardware, and this takes you right through into the areas of AI. So if you think about this, it's not so much 11 different narrow focused elements, but more of that bringing it together with the partners really getting to grips with the problem as a whole, and then bringing their experience together to bear in that. And that's been a really impressive part of the project, bringing that number of contributors together. Ultimately, the outcomes which I'd like to take us through here is basically in three parts. The first being the creation of specifications for a cybersecurity centre of excellence, the exploring of the economic and technological feasibility of CyRes and the resilience, and the development of commercial viability of a cybersecurity's operations. Ultimately, in summary of that, is really the aim to move cybersecurity into the operational domain for CAVs. Thanks, Mark. Just move to the next slide, please. Okay, so basically take you through now the first deliverable here. So this is the specification for a geographically distributed UK Centre of Excellence for road transport cybersecurity resilience. We have here the diagram that you see here on the right. In this petal diagram, the elements of what would be a testbed ecosystem cyber would be built up of these elements. The elements that you see here, the certification center element, advanced research into the next technologies that are coming, an engineering center supporting all the engineering and operational elements, and an operations center for all of the issues related to day-to-day and operations, and finally skills and modeling and simulation. So these are 6 core key elements of what would be seen within the test bed for an ecosystem. Some of the key points really just to sort of pull out from this, within the cluster, LinkedIn cybersecurity test bed, we would see an important point be about the integration with existing test beds, and I think we've heard this from some of the previous talks earlier today. So the existing ecosystem and what's there and how to connect that up. Another key point is the collaborative engineering and R&D capability is required to verify and optimize cyber concepts. So clearly R&D in this space, along with engineering excellence, is going to be key to provide the solutions. I also see here delivering cyber engineering from a point of view of test and operations are critical to ensure that the CAVs are resilient in operation. So understanding that we can actually ensure that. And last point really to pull out from this slide, we require to have a trusted and secure environment for independent cyber assessment, certification, informing policy, and very importantly, the skills development that would be required for us to build that competence here in the UK. Thanks, Mark. If we could move to the next slide. Thank you. Okay, so for deliverable 2, so this is about exploring the economic and technical feasibility of the CyRes methodology. So this is cyber resilience. A key point really just to sort of raise up here, and it's been discussed and touched on a little bit earlier, is we are critically moving from what is static analysis of systems to dynamic analysis of real-time monitoring. So as a vehicle becomes connected to this hyper-connected system. The CyRes base on measuring initially, detecting and understanding and reacting, and then a process so that resilience then meets the legal requirements of what would be a safe CAV system and environment. Just pulling out some elements here on the slide, it's a bit too small to read, but really just the point here is this is contained within the reports that have been generated. The key elements here of the design for cyber resilience is they have a design phase which includes what we existingly use, and we know about the V&V and the verification of vehicle design and verification. And then linked into that is the operation of events, and this is in a phased step process of known threats, scenarios, and guidance on what would be the next action. So clearly we can see that we're developing and building on what was originally very much our engineering bedrock of V&V, and now into a new system. Engineering difference was mentioned, I think, by Rich at the start, and it is absolutely critical. The The CIRES function itself is based on 3 principles and 6 certification arguments. They're detailed in the report, but the point being that typically in the electronics layer and the chip layer, mostly manufacturers will attempt to keep technology very much identical for yield and other reasons, and clearly we need to understand how we engineer that difference to lower the risk. In terms of the methodology overall, resilience and economic benefits are seen to be achievable within 3 years in the UK. The economic benefits is subject to an investment of 30 million in developing the appropriate tools and technologies. By 2030, in excess of 3 billion would be generated across industrial, medical, consumer, communication and automotive. CIRES would provide a springboard for innovation for companies at all layers, together with a direction for and measure of academic research into the coming years. Thanks. Move to the next slide, please. Thank you. Okay, so and the third deliverable, so this is developing the commercial viability for cybersecurity operations. The key areas to develop for the VSOC, so the Virtual Cybersecurity Operations Centre. Automation is of course critical, looking at new AI models, simulation, federated services. Cooperation, so a threats database and collaboration between different agencies would be key. And finally, the data management, so the governance, the privacy, standardization and sharing. So as shown there just in this diagram, but also mentioned here is the higher levels of automation and further research. The main conclusion here are that far higher levels of automation are essential within the VSOC. So there's a need to handle a variety of responses swiftly. There's a need to mitigate the already chronic shortage of skilled cyber analysts globally. So hence, further research in AI-based models and solutions to automate cyber defense in the CAV becomes absolutely vital. As a result, we must include resources to build, test, and evaluate simulations of epidemiological spreading and complex behaviours in these types of systems. Thanks, Mark. Last slide. Yep, thank you. Okay, so just in summing up, in conclusion, basically, so ResiCAV has successfully assembled the feasibility of cybersecurity resilience for CAVs. It set out 3 points here that we've mentioned, and you can see the reports to the right there. Firstly, how a UK Centre of Excellence for Road Transport Cyber Security Resilience, CYBER, would work outlining the required physical and virtual facilities. Secondly, the technical and economic viability of sustainable methods that enable CAVs and their infrastructure to detect, understand and respond to the cyber attacks. And third, how such a programme is commercially viable with a roadmap to success and details of the research required to increase automation. Just as a sort of final couple of comments, so ResiCAV have included an R&D roadmap, a focused approach to deliver high quality innovation in all of the deliverables. And this includes key and critical R&D, so it covers things like data models, metrics, threat intelligence, new methodologies for operation, self-healing systems, high integrity insurance. So basically that's the run through of the project. I'd just like to thank my ResiCAV team colleagues for the huge amount of work and for helping pull together what is a lot of work and summary into these slides, and just thank everyone for listening. Thanks very much.
3 questions, and I'll throw them over to select individuals who've spoken already today. And what I'm after is a 60-second answer to the question. So the first question actually came up a few times. Lots been questions asking around how do we balance the desire to publish our findings, and the reports that we've done have been made publicly available. How do we balance that with a need perhaps for thinking about how we classify these, how these reports might need to be classified, and how we don't open up vulnerabilities to new threat actors? So probably I'll throw this question to maybe Steve and Vic, and maybe Steve, if you want to go first. How do we balance the need to publish what we've been doing with the need to ensure that we're not opening up exploits to new threat actors? So Steve, if you want to unmute, maybe pop your video on. What's your 60 seconds on that question?
It's a really good question, and I don't have an answer. So this is probably going to take less than 60 seconds, other than to acknowledge the challenge, the requirement for some form of forum for responsible disclosure of what the threats are, and then so that bit perhaps needs to be separated from the testing and the mitigation of those threats, which should perhaps more properly be classified. But the threats themselves, there needs to be a forum for responsible disclosure of the threats, and some way of doing a meaningful risk analysis, which at the moment, without that understanding and database of the threats, is extremely hard to perform.
One of the other questions that came up, and we heard a lot on this webinar today around standards and the needs for standards. But at the very start, we heard actually that, and we heard it from the Zenzic project at the end as well, the need for diversity and heterogeneous systems provide resilience. So again, it is a question about the balance. How do we strike the balance between the need for standards and the need for diversity? I think Erica, perhaps if you could have a view on that. You've spoken a lot about standards, and then William and David, perhaps as well, if you can chip in. Erica, what's your view on how we balance standards and diversity?
In our context, as I mentioned in the slides, is most important is data standards. I think that the diversity that Zenzic, for example, mentioned is really about diversity, engineering diversity. Now, there is engineering diversity or embedding enough diverse engineering solutions in the shall I say ecosystem. It's a complex issue because that increases the complexity of maintaining, servicing, and whole spectrum of consequence involved. Now, whether personally, my view is that whether diversity can really enhance hardened security is something we need to research more into. But that's my brief sort of 60-second.
Excellent, Erica, thank you. And William, what's your view on how we strike that balance?
Sorry, is it still me?
No, for William. Oh, William, your sounds, we can't hear you there. Oh, I think maybe turn your video off, William. I think the quality is pretty low. Turn the video off, maybe we'll be able to hear you.
Me now.
That's just about, yeah, maybe a very brief answer.
There.
William, I think you're cutting in and out a bit there. Maybe we can follow up with your answer to that question afterwards. David, from an IDIADA perspective, if you've got anything to add to the balance of standards and.
Hopefully this works.
Yes.
I think from our point of view, the standards have really got to talk about the approach, the high level, how are we going to look at securing the system. If you kind of think of some analogies, you can half build a moat, half build a brick wall, half build something. But if you don't complete and do any one of them, you don't get a secure system. So what we've got to do is publish the approaches, the ways we're looking at it, where we need to have the complete security to the system. But what we don't then do is give out all the details. Those are the parts that stay behind the fence, as it were. Hope that helps.
Thank you. Yeah, no, I think so. And a question we could go on and on to ask. Just very finally, question just for Paul and for Chris from the CCAV Shield and ResiCAV projects. A challenge thrown down on the chat on the questions there is in 60 seconds. How do you pitch to a government minister what we need to do in the next 18 months to get to the point where we can realise a lot of these project recommendations? So in 60 seconds, and Paul, maybe I'll throw you under the bus first to answer that one. But what's your 60-second pitch to a government minister in the lift on the way up? What do we really need to focus on the next 18 months to make all of this a reality?
Thanks, Mark. Thanks for the question. I think it's important we've got a really joined up message. I think the fact that government have set up CCAV and Zenzic is a really good thing. And then the fact that the Automotive Council and the link with the work you're doing has recognised cybersecurity as core. I think if we take the recommendations from the ResiCAV and the rest of the projects that are here today, and we get a simple unified message about what we want and what we need to make it safe to connect, I do believe that we can get the attention of government. And I do believe we can do that through the recommendations that we have, building on the great, bedrock we already have, and what's been set out in their own requirements in terms of the sector deal and so on, and for mobility. So I think we can build on the message that's there. I don't think we're starting from scratch.
Excellent. Always good to start from a good place and start from nowhere. And Chris, just finally from you, any thoughts on what's the key things we need to, a government minister needs to know to make this happen?
Yeah, I think if we look at the way that the CAV ecosystems are developing generally, if we look at areas such as the United States, for example, the lack of a kind of a centralized regulatory system, something that's actually on the ground and proven to work, it's leading to more and more of a system of self-certification. It seems to be kind of a spreading solution to the technology essentially being held back by the lack of regulation. And we've seen examples of self-certification going horrifically wrong. So I'm thinking of the Boeing example, for instance. So I think if the UK can push forward and actually demonstrate a solid working example of a cybersecurity centre of excellence and a regulatory system around which people can agree and coalesce, then I think there's a good chance that will take root here and it will be able to spread internationally.
Chris, thank you. Yeah, very good points. A difficult question, often to answer, and thank you everybody for submitting all of those questions in. Like I said, what we'll endeavour to do is send the questions round to all the panellists and hopefully collate some answers which we can share in due course. Just to finish off on today's webinar, hopefully you found all of those insights interesting. You'll be able to contact each of the projects following up on this to further get to know more what they're about, and hopefully we can use this as a springboard to build some really great relationships. Next up, we've got CCAV are going to spend just a few moments just articulating what's next. So these projects now are pretty much done and dusted, moving on each project to exploit, but what's next from a CCAV perspective? So David, over to you just to take us through what happens next.
Thanks, Mark. Thanks again for all of the presentations. It's been a very interesting couple of hours, and some very interesting work has gone on. So my original plan for what next was to be talking about launching competitions. Unfortunately, we haven't been given permission yet to launch new competitions this year, so I can't go into details of that. But I think the CCAV leadership, myself included, are very keen that we build on the lessons identified from this work and we continue investing forward into cyber resilience and how the UK manages that as part of our safety and security aspirations. Likely the first thing we're going to be doing is looking at funding some of this work to help inform a BSI PAS, publicly available specification. Nick, I believe, is coming up on the call after me, so he can talk a little bit more about PASs in general and where CCAV has been working with them to fund those. But certainly some building on the guidance from DFC's 1885 PAS looking at where we can put some starting points in for the CAV ecosystem on how we can assure cyber resilience or even work towards cyber resilience. Long-term aspirations, hopefully, as we come out of the coronavirus lockdown, we get some funding, we will be looking to launch competitions in October, and again, there will be certainly some cyber funding there. I would say that it's not just this cyber feasibility work where we funded cyber research. Some of our wider Intelligent Mobility Fund over the last 4 years has funded a variety of elements of cyber research. And if anybody is interested in getting in touch and talking to any of our other projects, mine and Jess Deloy Hyde's email should be coming out to you when Natalie sends you the update from this conference. But yeah, overall, there will be some money coming, there will be some cyber competitions, and we are taking on looking at all the recommendations from the work and looking at how we best support those next steps, be that with CCAV or any of the other government agencies that might have a role to play in this in the future. Thank you.
David, thank you for that. And yeah, always we're in slightly unprecedented times. What we'd hope to be planning to do, as David says, is looking at competitions. We are fighting other battles on other fronts, all of us, and different working patterns. And that brings on to the next short section from Neil Ryan from Innovate UK, just to talk through some of the things that they've been doing and a little bit about their COVID-19 business support package and kind of what that means for us and these projects. So Neil, over to you.
Yeah, good afternoon, everybody. Hopefully you can hear me and see me. So my name's Neil Ryan. I work in the team that delivers this activity within Innovate UK. Can I just extend my thanks to the project teams for their hard work over the last 3 months. I know you've been extremely busy. It's been fascinating to hear your efforts and your recommendations this morning. So I look forward to working with David and the Zenzic team to take that stuff forward over the next few weeks and months. So I'm conscious of time. Got a few slides on what we're up to at Innovate UK in terms of our response to coronavirus, which I think will be of interest to many of you. So more details are to follow, but I'll share with you what I can this morning. So next slide, please. Okay, so we've been extremely busy at Innovate UK over the last few weeks, responding as part of government to the unprecedented challenge of coronavirus. There's a number of activities that we've now put into place and will be putting into place over the next few days and weeks. So I'll cover some activity that we're doing to support existing projects and existing companies. So I know that many of you who have obviously now completed your CAV cyber projects will be involved in other live projects with us, and there's some specific measures we've put in place to help companies, help projects as much as possible. So I'll mention some of the details around that. I'll also mention what I can about the new funding opportunities that we're expecting to launch in the coming weeks, including our part in a £1.25 billion package of support that the Chancellor announced just a week and a half ago or so. There is also some additional support being provided through EEN, which is the Enterprise Europe Network, which is kind of direct business support to predominantly small companies to help them look for new opportunities and navigate their way through the support landscape at this obviously difficult time. And then lastly, what we're doing at Innovate UK is obviously part of a wider package of support that the government has rapidly put into place, everything from the furloughing scheme through to the activity of the British Business Bank in terms of the loan schemes and the bounce back loans that have been put in place, and all of the other wider activity that's going on within government. But certainly the key message from Innovate UK is that we're here to help. We're here to help our existing customers and existing projects and companies, but also to provide some additional funding to the UK's ecosystem or innovation ecosystem over the next few weeks and months ahead. Okay, next slide, please, Mark. Okay, so if you're involved in an existing live project, this is kind of the slide for you. So we have made some changes to some of our internal processes to help existing projects, live projects, manage some of the challenges associated with coronavirus and the slowdown in the economy. So all of the MOs have been sent detailed guidance on what we can now do and the additional flexibility that we are able to offer projects. So if you've not spoken to your MO recently, then please do touch base with them, and you can get further details from them on what we're able to do. But essentially, it's things like 3-month time extensions for projects using a fast track process. We've made some changes to the requirements around independent accountants reports, because that could be a barrier to you receiving funding. So we've made some adjustments there. And we've also looked at and can offer a reduction in the final grant retention rate, which is normally 15%, down to 10%. And again, that frees up money that can flow out to projects sooner than perhaps would otherwise be the case. So again, if you're in a live project, suggest you speak to your MO. Your MO has lots of details about some of the things that we are doing to try and help live projects to get cash out to you quicker than would otherwise have been the case. Okay, next slide, Mark. Okay, so yeah, so there is new money coming. New innovation funding is on its way. We actually launched our first rapid coronavirus response competition at the beginning of April. That was an initial £20 million competition. That was designed in 2 weeks, was open for 2 weeks, and we had nearly 9,000 applications into that £20 million pot. That was a broad competition looking at everything from retail to education to transport, right across the economy, looking at small projects, 50k awards up to 6 months in duration. If you applied into that competition and you're waiting for an answer, we are working extremely hard behind the scenes to get a decision out to the winners as quickly as possible. Like I say, we've had an unprecedented demand for this competition. More people applied for this single competition in 2 weeks than applied for all of our funding in the last 12 months. So there's been many applications and assessments to go through, and we're working very hard to get an answer out to the winners and the unsuccessful bidders as quickly as possible. So that was the first part. That's been delivered, and hopefully the projects will be told soon and start soon. The next big announcement was this £1.25 billion package of support that was announced by the Chancellor on the 20th of April. £750 million of that will be delivered through Innovate UK. Again, that will be aimed at existing customers and existing projects, but also supporting new projects to get started. And so the details of that we're expecting to be announced within May, so in the next 2 weeks or so. So if you are looking for future funding opportunities, then do follow us on Twitter, look at the website, follow us on LinkedIn, because that will be the best way for you to find out what the details are of those schemes, both the support for existing projects, and potentially part of that is around accelerating payments to existing projects, but also the new funding, the new competitions that we're going to be launching, both grant funding and loan funding in the coming couple of weeks or so. The other £500 million part of that package is an equity fund that's being established by the British Business Bank. So that's around equity finance for high growth companies looking to secure up to £5 million in total. So again, if you're looking to undertake a new funding round, the British Business Bank Future Fund might be a suitable source of funding for you. So that's being delivered by the British Business Bank directly. Okay, next slide, Mark. Okay, so on this slide, which I'm sure will be circulated afterwards, there's some links for you to follow to get further information. Obviously, all of the support the government is offering is accessed through gov.uk, which is obviously where the Innovate UK website sits as well, and the British Business Bank has details of the schemes that it's running as well to help companies access the finance that they need. Like I say, in terms of the future funding, announcement, the best thing to do is to follow us on Twitter or LinkedIn, because that will be the place where we announce the details first, and then you can begin to see how the schemes will work and what might be suitable for you as individual projects or individual companies. Okay, I think that's it from me, Mark.
Neil, thank you very much. If you've got any questions for Neil off the back of that, either pop them in the question chat now, and we'll scoop them up with the rest of them, or you should have Neil's contact details already, or we'll be sharing them after this. And do feel free to do make use of those. A lot of really useful things and some support available. I certainly know as we look at these projects that have been sort of impacted partway through by lockdown and various complications, looking at how we draw together a lot of what's been done, there's opportunities there. So we are exploring how we could continue to work together across all these different consortia to look particularly at how we might bring together, in the same way we've done a report around the test facility, what does that look like for the methodologies piece of work. So Neil, thank you for that. We are very slightly over time, but just one last topic for today before I can release you back to whatever you've been doing. So Nick Fleming from BSI just wants to have a quick talk to you about the upcoming plans for the BSI Cyber PAS. So Nick, over to you.
Hi Mark, thank you. Hopefully you can hear me okay.
Yeah, loud and clear.
Great, fantastic. So I don't have any slides, and I'll do my best to keep this to time. As Mark said, I'm Nick Fleming. I lead on CAV standards at BSI. You know, so far this webinar has been incredibly helpful from my perspective, not just to hear more about the studies, but there's been lots of useful comments and insights from standards that I'm really keen to understand more about. Hopefully most of you are aware of BSI, so we're the UK's national standards body and member of ISO, IEC and other international standardizations. And hopefully you're also aware of the BSI CAV standards program that's being funded by CCAV in conjunction with DFT, Innovate UK and Zenzic. And this program is a 2-year program that has various aims looking to accelerate and support the development of CAVs in the UK, supporting the UK as a global centre of excellence, and a key one, I think, in the context of cyber in particularly, informing and influencing the development of future international standards in relation to CAVs to drive exports, FDI, and the UK's capabilities. The programme so far has delivered PAS 1881, which is the specification for supporting autonomous vehicle trials and development testing that you may have seen alongside the Zenzic safety case framework, and more recently some guidelines for development of control systems with PAS 1880. So as part of the programme, we've been looking at various areas, including safety testing and generally safety critical issues related to cybersecurity. Obviously, cybersecurity is not new ground for standards, and several standards have already been mentioned today. A combination of PASs, ISO standards and other forms of standards. SAE have a number of standards in this area. BSI published 2 PAS documents at the end of 2019, one of which has been mentioned, PAS 1885, and also PAS 11281, which looks at the impact of security on safety. Both of those PASs are currently recognised, mentioned in the Code of Practice, and I think various speakers, Steve from Spirent, William, Erica and David have all talked about standards in different ways. So the main reason for wanting to speak here today really relates to the programme, and earlier this year ASIN completed a piece of work for BSI started back in 2019 and led by Peter Davies of Thales, and also involved in ResiCAV. And that project was to review the existing landscape in terms of cyber standards and to provide some clarity in terms of technical gaps in coverage, opportunities perhaps for standards and some of the priorities in terms of actually supporting safe deployment of CAVs going forward. So the report that outputted there, hopefully most of you will have seen that. That report proposes a new methodology for achieving operational cyber resilience. So the intention being to supplement relevant existing standards that perhaps have taken this well-trodden security by design engineering approach, as you might see with documents such as the ISO SAE 21434 draft that has been mentioned. So it's really supplementing that with more of an operational focus or methodology. So hopefully you've seen that. David Webb of CCAV kindly sent out an email back in March, I think it was the 20th of March, out to the various feasibility study teams with a copy of that report. And that report includes a proposed methodology and a draft potential contents for a PAS, in addition to a number of questions. So we are now considering whether to use the methodology in that report as the basis of a new cyber resilience PAS. Initially, we feel that could take the form of a set of guidelines that would capture the overarching framework and may evolve and become something the UK can use to establish leadership in the field internationally. So the email, hopefully you've received it, and it outlines the three key questions that we're looking to get feedback on in relation to the methodology. One being around whether the work that you've done in your feasibility studies in any way supports or validates the need for a PAS in that area, and in some cases it feels from what you've said today that it might. Whether you can see, I suppose, the development of a PAS in that area as being of value to the UK, and also whether you would see benefit in contributing some of the outputs of your research into that methodology. So essentially my kind of call for feedback today, I suppose, is really in relation to that email, and we've had some responses to date from several of the feasibility study groups, and that's been fantastic. But we'd like to hear from you if you haven't yet responded to any of the questions that I've mentioned, specifically around this proposed PAS that features in the report. But equally, if you have any other thoughts regarding the future direction of cyber standards in this area, and some of those have been mentioned today around data and comms and some of the challenges there. Again, very keen to hear from you, and the timing is good for this because BSI is currently in the stage of starting to identify the onward roadmap for standards to support the CAV programme, and that will involve us looking again at what is happening in the international landscape and what the UK should perhaps be taking a lead on in terms of cybersecurity and broader CAV standards. So that's it from me. Please reach out to me either directly via Zenzic, who are happy to share my email address, or by responding to David Webb's original email, which I think I was copied into. And equally, as I said, if you want to get a bit closer to the work that BSI is doing on the CAV programme more generally, really pleased to hear from you. So that's it from me, Mark. Hopefully I've kept that as brief as possible.
Yep, Nick, perfect. Thank you very much for that. And just to echo Nick's words, I really would encourage you to respond back to that email, get involved. One of the things that we're really keen on is that the work we're doing here doesn't just stop with feasibility studies, but has an onward journey. We've outlined in our report that journey towards a cyber centre of excellence and test facility, looking at what future kind of competitions and programmes might be that help us to join that in as part of the broader CAM Testbeds UK work. And I think what Nick has outlined there, and some discussions that I've had with a number of the projects, really is about drawing together the other parts, one of the other public deliverables that were produced around the methodologies and processes. I think something that I'm particularly keen on is to understand how do we join those together in something that is cohesive and collaborative. And broad in its approach. So I think that the PAS is a way of doing that. Potentially, if there's appetite, there could be a further work just to draw together, a summary document, bringing together all of the methodologies, potentially, working with Innovate UK and funding there, and working with CCAV. That might be something that we could continue this piece of work to ensure that what you delivered has longevity and has a route to deployment and making it operational. So that's, I guess, a plea from me. Please, project leads, do get in contact if that's something that you think there's an appetite for. Do respond to Nick's email that came out by David Webb to have your say on this kind of future PAS for cybersecurity. So hopefully you have found this webinar as fascinating as I have. It's great to get a little insight into the breadth and the depth of what the projects you all have been delivering over what has been a very challenging, very short, very intense period since the beginning of the year. We will be following up tomorrow or Friday morning with an email to everybody who has attended, sharing the slides, hopefully sharing contact details of all the panelists and presenters. We have been recording this webinar, so we'll make that available. You can share that with people who've been unable to attend, or if you've not been able to attend all of this webinar, you should be able to get access to that. Again, with links to things like the report that you can download and the blogs and various things that are going on. So without further ado, just to say a final thanks from me and the Zenzic team to all of you who have contributed, questions, panelists, those who have attended to listen in. We hope you found this interesting. We hope that you pick up what you've learned today and take it onwards. I hope it helps your organisations in what you're doing. So thanks once again. We will be sending around all of the questions and answers and all the slides follow up in the next couple of days. So thank you very much for attending and hope you've had an enjoyable morning. Thank you.